this lesson is the final lesson in Unit 3, and it's going to explain to you how to actually solve now radical equations. You've done the inverse and it's solved for variable, and it's essentially going to be similar steps, but you're going to say, okay, we have this radical equation, we need to solve or find the value for x. So equations with radicals that have variables in the radicands are called radical equations. Remember, guys, radical is just your square roots, your cubed roots, fourth roots, all that good stuff. So an example of a radical equation is the cubed root of 2x plus 7 equals 3. So there's three main steps when you guys are solving these radical equations. The first one is that you guys are going to want to isolate the radical to one side. So if there's like the radical plus something, you're going to want to move that plus something to the other side. Or if it's something multiplied by the radical, you're going to want to divide by that value to get just the radical by itself. So step 2, it says raise each side of the equation to the same power as the index to eliminate the radical. Solve the equation. So let's take a look at those first three, and let's actually do number 3. So example 3, it says 2 times the cubed root of x minus 3 equals 4. So divide by 2. Cubed root of x minus 3 equals 2. So we got that radical, that cubed root radical, by itself. So now that we have done that, we need to raise each side of the equation by the same power that the index is. So if the index is 3, we need to raise our equation to the third power. So what happens is that index of 3 and that power of 3 cancel, and you're left with just the x minus 3 equals whatever 2 cubed is, which is 8. So now you guys know what to do. If you're trying to solve for x, you just need to add 3. Now, it says solve each radical equation, but be sure to check for extraneous solutions. Extraneous solutions are just solutions that aren't true. So when it says to check for extraneous solutions, that means if you get a solution of x equals 11, you need to go and check and make sure that x equals 11 doesn't make underneath your radical an impossible value. So let's plug in cubed root of 11 minus 3. Now, for the cubed root, it's not really going to matter because you guys can take the cubed root of any value, but you're going to really need to check when you guys have the square roots. Because if your solution, when you go to plug that back in, if it gives you a negative value underneath the square root, it's not a solution. So you just need to check. But for the cubed root, it's going to be fine. So we'll have 2 times the cubed root of 8 equals 4. And you just need to make sure, okay, that it does equal that. So the cubed root of 8 is 2. 2 times 2 equals 4. So check, make sure that it's true. And again, if you have even root radicals, you just need to make sure that when you plug it in, you don't give a negative underneath there. So that's it. So you guys can go ahead and try number 1 and 2. I'm going to move on and try number 4 and 6 with you guys. So this is example 4, and it says in a hurricane, the mean sustained wind velocity v in meters per second is given by this equation. So the velocity of pressure equals 6.3 times the square root of 1013 minus p. So they give you the function. And they're saying P is the air pressure in millibars at the C center of the hurricane. So estimate the air pressure, so estimate P at the center of a hurricane when the mean sustained wind velocity is 54.5 meters per second. So let me write this down. So VP equals 6.3 times the square root of 1013 minus P. So if this is your velocity, that's where we're going to plug in 54.5. And we're going to find P. So if this is 6.3 times that radical, if we're trying to get the radical by itself, because that's the first step, we need to divide both sides by 6.3. So 54.5 divided by 6.3 gives you 8.65. And then the square root of 1013 minus P. So now that the radical is by itself, and again, if you don't see an index, you have to know and assume that it is a square root. So the power we want to raise this to is going to be 2. So 8.65 squared is 74.8. And on the right-hand side, we just have 1013 minus P. So, what do? We subtract 1013. So subtract 1013, both sides. 74.8 minus 1013, or 1013, gives us negative 938.2. And it's going to be negative P, so don't forget to bring that negative down. So the last thing to do is divide by negative 1. So your estimated pressure is going to be about 938.2 millibars. And to be honest, I don't know what millibars are. But that's it. So again, same process, guys. We're trying to get that radical by itself, and then we're solving for the variable. For number 6, we're still trying to solve for x, so we still need to isolate the part that is raised to the power. We're just going to use radicals to undo the power in this case. So there's no radical we have to undo here, but we are going to use that to get to the end result, or to get to our solution. So if we look at this, if we're trying to get the x plus 2 to the 3/4 by itself, the first thing I'm going to do is add the 1 over, so nothing crazy there. So we'll still have x plus 2 to the 3/4 power equals 8. So now, to undo this power, I'm going to raise it. Instead of taking a square root of something, I'm actually going to raise it to a power that's going to make that exponent 1 and essentially make the exponent disappear. So 3/4 times what gets us 1? Well, 4/3. But remember, what you do to the left, you must do to the right. So 3 times 4 over 4 times 3 gives us 12 over 12, which is 1. So anything to the first power is just itself, and that leaves us with x plus 2. Now on the right-hand side, I'm going to write that, or rewrite that, as a radical. So I'm going to rewrite this as the cubed root of 8 to the 4th. So what is the cubed root of 8? 2 to the 4th power is 16. Subtract the 2 over and get x equals 14. So that's it. So to undo that weird power that's a fraction, multiply it by the reciprocal. Raise it to the power that's the reciprocal of the exponent you currently have.